Now we're going to start solving equations. We have an equation where we had just expressions before. This is an equation because it has an equal sign. When it has an equal sign, we can solve. If I start here with minus 4 plus x equals negative 2. Now, always when I have an equal sign, as long as I do the same thing to both sides of the equal sign, my value is always going to stay the same. Let's look at y. Let's say I start with 2 equals 2. If I multiply this side by 3, it's going to be 6. If I don't multiply the other 2 by 3, we're not going to have anything equal. But if I multiply them both by 3, I get 6 equals 6. I can subtract 2 from both sides. I get 4 equals 4, and so on. As long as I do the same thing to both sides, what I'm doing is I'm keeping the equation equal, both sides of the equation equal to each other. What does that mean for this problem? I want to do opposite operations. If I have a negative, the opposite would be add. If I have a positive, the opposite would be subtract. If I have multiplication, I divide. And if I have division, I multiply. Those are opposites of each other. Now let me show you in this problem. Well, I want to find out what x equals. So in the end, I want x equals something, which means this negative 4 here is in my way. But if I add 4 to both sides, negative 4 plus 4 is 0. 0 plus x is equal to, well, I added 4 to one side. I have to add 4 to both sides. This becomes 2. 0 plus x is x. X equals 2. That's my answer. Now we're solving and we have fractions. We do everything the same and we know how to add, subtract fractions. We start out with negative 4/9 equals z minus 2/7. Well, remember what I said? I want the z by itself because I want to know what z is equal to. What would I do? I could add 2/7 to both sides. Negative 2/7 plus 2/7, this becomes 0. That means on the right side of the equation, I just have z. And then I have z equals negative 4/9 plus 2/7. And if you watch the video on finding the least common multiple, least common divisor, I can see that if I do a factor tree, 9 is 3 times 3, and 7 is just 7. And I said, if there's nothing in common between those two factors, which there's not, this has 2 3s, and this just has a 7. What I do is just multiply them times each other. That means I multiply this by 7/7, and this by 9/9. What I get is negative 28/63 plus 18/63 equals z. And then, since I have a common denominator, that's really the same as this. You don't have to go through all these steps. I'm just trying to go through the steps to make it easier. Negative 28 plus 18, negative 10 divided by 63 equals Z. And I know that I cannot simplify that because 63 is not divisible by 2 or 5, and that's all that 10 is divisible by. That means my answer should be negative 10 divided by 63. And here we have division because n over 3 is the same as n divided by 3. Remember, we have to do the opposite operation. I want to get rid of that 3 that's with that n because I want n equals. And if I multiply both sides, because remember, I'm dividing, so I multiply by 3. And 3 divided by 3 is equal to 1. 1 times n is equal to n. I get n equals 120. Now I have 10 equals 8 times u divided by 3. And what do? I do the opposite operation. First, I always want to get rid of my denominators because they're always a problem. What I'm going to do is I'm going to multiply both sides by 3 because I'm dividing by 3 on the right-hand side. 3 over 3 equals 1. 1 times 8u equals 8u. I get 3 times 10 is 30 equals 8u. Now I have 8 times u. The opposite operation is division, which means I'm going to divide both sides by 8. 8 over 8 is 1. I get u equals 30 over 8. Now I'm going to divide the numerator and the denominator by 2. And I get 30 divided by 2 is 15. 8 divided by 2 is 4. And there's no other factors in common between 15 and 4, which means my final answer is u equals 15 over 4. I have 292 is equal to 63 minus w. First thing I'm going to do, since I want to get w by itself, sometimes we call it isolating the variable. So maybe you can call it isolating w. But what I need to do is I need to get this 63 to disappear from that side. All I want over on that side is w. Since I have a plus 63, I subtract 63 from both sides. This cancels, and I get negative w here. Now let's subtract. I get 9. 8 minus 6 is 2, and then 229. 229 is the final answer for negative w, but I don't want to know what negative w is. I want to know what w is. Well, how would I do that? A negative times a negative is a positive. So why don't I multiply this by negative 1 and this by negative 1? What I get is negative 229 is equal to positive w because I have a negative times a negative. Basically, you can see that the negative can just move to the other side and multiply. If this was negative 29 and we multiplied by a negative, it would be positive 29. And that's really it. Now we have a few things happening at once. Notice I have a plus and I have a division. Before I just had one or the other. With PEMDAS, We use this when we evaluate expressions. If I want to solve, I almost do it backwards. What I mean by that is I'm going to do addition and subtraction first. And there is a reason for it. The reason is if I do multiplication and division first, and I have to start dividing, and they don't divide evenly, I'm going to end up with fractions. And I don't want to turn things into fractions if I don't have to. So adding and subtracting usually helps that. For example, remember what I want to do is I want to isolate my R. Means I have to get everything away from R and just have R equals. And I'm going to start with adding and subtracting, which means I'm going to subtract 5 here from both sides. This becomes 0, and I get R divided by 5 is equal to 9. Well, now I just have a multiplication left, which means I'm going to multiply both sides by the same value. As long as I add to both sides, subtract from both sides, multiply to both sides, or divide to both sides, I'm not doing anything wrong. And then I know that 5 divided by 5 is 1. And 1 times R is R. 9 times 5 is 45. My final answer is R is equal to 45. Notice I did adding and subtracting first. I did multiplication and division second. We didn't have any exponents. We didn't have any parentheses. Nothing to worry about. I start with d over 2 plus 5 equals d divided by 7. Now remember, I want to get all the variables on one side. That means all my d's have to go to the same side. And I'm going to move this d over to the other side by subtracting, because I already have the 5. I don't want to put the 5 on the other side because then I'm putting it with another d. I'm not going to evaluate this yet, except I know this is 0, which means I have 5 equals d over 7 minus d over 2. And again, I just need to find my least common denominator. And I look at 7 and I look at 2, and again, they have no factors in common, which means I multiply them times each other. I have 5 equals d over 7 times 2 over 2 minus d over 2 times 7 over 7. My next step is d equals 2 times d divided by 14 minus 7 times d over 14. And look, now I have a least common denominator. This becomes 2d minus 7d divided by 14. I'm going to rewrite this as 5 equals, and I can subtract 2d minus 7d. 2 minus 7 is negative 5 times d divided by 14. The next thing I need to do is I need to get rid of that denominator. How do I get rid of that denominator? Same as I have for all the rest of the videos. I'm going to multiply both sides by 14. 14 times 5 is 70 equals minus 5d. And I'm going to come over here. I have 70 equals minus 5d. And I don't like that negative 5 in front of the d, which means I need to divide both sides by -5. These cancel, and I get positive divided by a negative, negative. 70 divided by 5, that's 14 equals D. D equals -14. We start with 3p plus 2 divided by 3 plus 2p plus 3 divided by 5 equals 4. When we have fractions, we have to get a common denominator. We could split this up, but it won't be that helpful. What I mean by we could split this up, even though I'm not going to do it this way, I can say that this is equal to 3p over 3 plus 2/3 plus 2p over 5 plus 3/5. The reason I'm not going to do it that way, it might even be a little faster and easier. However, it's unlikely this will work most of the time. That's why I'm not going to show it to you that way. I'm going to show it to you. I'm going to go from here to here. I look at my denominators 3 and 5. 3 doesn't have any factors. It's 3 times 1. 5 is prime. It's 5 times 1. Again, they have no factors in common, which means I multiply them times each other. I have 3p plus 2 over 3, and I have to multiply that plus 2p plus 3 over 5, and I'm going to multiply this by 5 over 5. And multiply this by 3 over 3. Now we multiply. We have to distribute that 5 to both the 3p and the 2. Let me write it down. Let me take steps. This would be 5 times 3p plus 2 divided by 15 equals plus 3 times 2p plus 3 over 15 equals 4. Now I have 15p plus 10 over 15 plus 6p plus 9 over 15 equals 4. And since I have a common denominator, I can add them all together. I can add 15p plus 6p, because they're like terms and they have a common denominator, which gives me 21p. And then I can add 10 and 9 plus 19 divided by 15 equals 4. 21p plus 19 divided by 15 is equal to 4. And what's the first thing I want to do? Whenever I have a denominator, especially when it's just a constant, I multiply both sides by that value. I can cancel 15 with 15. I get 21p plus 19 equals 60. Again, I want the p by itself, so I'm going to subtract 19 from both sides. I get 21p equals 41. The last thing I'm going to do is divide both sides by 21, which gives me p, because the 21 cancels with the 21, equals 41 divided by 21. It's not too bad once you get the hang of it.